Hi, I'm Simon, and I'm here to talk about loose coupling, pure dependency injection, and the composition route. But before we get started, I just want to congratulate you on your 100th meetup, and I think we should give the organizers a round of applause. It's truly an honor to be here to celebrate it with you. Thank you so much for inviting me to your beautiful city. So, as I said, I'm here to talk about loose coupling, pure dependency injection, and the composition route. But I'm also here because I hope that I can inspire you to think about how you compose your Swift apps. And I know there are some Android developers in the audience as well. I think most of the topics we'll discuss today also applies to Android development. But yeah, sorry, I'm an iOS developer. So I've been building iOS apps since the iPhone 3GS came out, so that's about 15 years ago now. And during late nights and in the weekends, I tend to work on some of my own apps, including Runestone, a text editor for iPhone and iPad. You can sort of think of it as a lightweight notepad.exe. Sorry, Martin. Yeah, I also work on Scriptable, an automation tool for running JavaScript on your iPhone and iPad. And my latest addition is Festivitas, a Mac app that puts festive lights on your dock and menu bar. Go check it out. It's holiday season is among us coming up. During the day, I work at a company called Fremne. We are an agency with studios all around the world. I work from our studio in Copenhagen, in beautiful Copenhagen, Denmark. But as of recently, we also have studios in Poland as well. We have a focus on mobile development for iOS and Android. And the topics I'll cover today are some that I've dived deep into over the past couple of years to improve our code bases at Fremne. So, achieving loose coupling with pure dependency injection and the composition route. It's quite the mouthful of a title. But we'll go over these topics one by one, and we'll kick things off by reminding ourselves what loose coupling is and how it relates to dependency injection. So, loose coupling ensures that our code base is flexible enough that it can adapt to changing requirements and accommodate new features with minimal changes needed. Loose coupling also ensures that our code base is maintainable because components have well-defined boundaries, so we can fix a bug or introduce a feature in one part of the code base with a reduced risk of unintended side effects in other parts of our system. We know from the dependency inversion principle that one way of achieving loose coupling is through abstractions. The dependency inversion principle tells us that high-level modules should not depend on low-level modules. Instead, they should both depend on an abstraction. And just a reminder, an abstraction in Swift can be a protocol. So let's look into how we can actually write loosely coupled Swift UI-based app, or loosely coupled Swift code in general. So I like to work from coffee shops. So I built this app that lets me track and rate the coffee shops that I've visited. And we'll use this as an example going throughout the talk. And I just want to show it to you so you have some pictures on your mind when we look at some of the code later. So in this app, I can sign in and I can create an account. In this case, I'll proceed by signing in with my email and my password. Once I'm signed in, I'll see a map. Should be a second. There we go. Then I see a map of the nearby coffee shops, and I can pan around it. You'll notice the black dots are nearby coffee shops that I haven't visited. Then there's a yellow dot, that's a coffee shop that I have visited and rated. I'll go ahead and select a coffee shop. So I recently went to this coffee shop called Comets. It's a great coffee shop in Paris. In fact, it's part coffee shop and part vinyl shop, which is great for a vinyl lover like me. So I'll go ahead and rate it 5 stars, and I'll leave a note to remind myself why this is a 5-star coffee shop. Then, with that rating done, let's dismiss these details and see what happened. Now, the color of the marker changed from black to blue, indicating that this is a highly rated coffee shop compared to the yellow one, which is a lower rated coffee shop. Then I have my profile, where I can log out, and I can see a list of the coffee shops that I've previously visited along with their ratings. That's the app, really. So let's consider for a second, or for a moment, I would say, how we can build a map view like this. So our code might have a Swift UI view called Coffee Shops Map View, and it has a body, and its implementation is left out for brevity in this case. Then we might have a database, a Swift data coffee shops database that can provide us all the coffee shops to be displayed on this map. We'll add a reference to that in our view. A property called DB will create and instantiate the Swift data coffee shop database so we can display our markers on the map. Well, we have a problem now because we just introduced tight coupling in our view, or in our code base in general. And that's because the view, the consumer of this dependency, that is the database, the consumer is the view, the dependency in this case is the database, the consumer creates and owns this dependency. This makes it difficult to swap out our dependency, for example, to stop data, mock behavior, use it in a unit test, or just because we need to swap out we need the data coming from a different data source at some point. And in the context of dependency injection, we call this the control freak anti-pattern, where the consumer creates, initializes the dependency and holds a reference to it. So let's get rid of this tight coupling. And we found out a second ago that one way of getting rid of tight coupling is by introducing an abstraction. Or one way of achieving loose coupling is by introducing an abstraction. So we'll go ahead and do that. We have this coffee shops repository. That's a protocol in this case. And then we'll make our database conform to this abstraction, conform to this protocol. That's straightforward in this case. And then we'll swap out the property in our view, the DB property. We'll swap that out for the repository, for our repository. So now we depend on something conforming to the coffee shop's repository protocol. And whoever initializes our map view will need to provide something conforming to this protocol in the synthesized initializer. And with that, we actually achieved the loose coupling, and we did that using dependency injection. Whoever initializes the map view will need to provide us a repository. And we can use that as a benefit in our unit tests, in our Swift UI previews, or if we need the data coming from a different data source at some point. So we just learned that dependency injection is a technique that enables loose coupling. Now, with that, let's turn our attention to dependency injection. Let's just remind ourselves that there are three types of dependency injection. Initializer injection, where a dependency is provided to a consumer through the initializer. Then there's method injection, where a dependency is provided to the consumer as an argument in a function call. And then there's property injection, where the dependency is assigned to a consumer's property. A common example of this is the delegate pattern, which is commonly used in UIKit-based apps. We will mainly focus on initializer injection. Initializer injection is ideal for dependency injection because initializer injection is fail-safe by design, as the initializer will enforce the relationship between the consumer and its dependency. And also, initializer injection is just great for discoverability because when we initialize something in Xcode, another editor, autocomplete, will show us the dependencies that we need to provide. In this case, we create an authenticator, and we're immediately told that we need to provide something conforming to the credential storing protocol. Nifty. So let's have a look at what happens when we start to adopt initializer injection in our code base. And we'll do that by examining the profile view that we saw earlier. So in order to build this, we might have our authenticator from before. That's an object conforming to the authenticating protocol. It has a dependency on a credential store. That's something conforming to credential storing. And then, of course, we have our view, our Swift UI view, the profile view. And it has a dependency on the authenticator. It also has a dependency on a repository that contains all the coffee shops that we have visited. Now, we'll start noticing what's happening here. We're actually dealing with an object graph. Profile view depends on a repository. It also depends on the authenticator conforming to authenticating, which in turn depends on something conforming to credential storing. But this is only part of our object graph. The object graph for our app is much larger than this. We also have the onboarding view that we saw earlier, the map view, and so on and so on. And just a reminder, the edges or the arrows here represents dependencies. It's not the onboarding view that creates the authenticator and so on. Rather, the onboarding view depends on the authenticator. But the objects in this graph, they don't have to live in our app target. Me, for example, I'm inspired by an approach presented by Airbnb, where they moved their UI and business logic into Swift packages. specifically into feature packages. So all features in their app lives in separate Swift packages, along with some packages containing cross-cutting concerns, that is, logic shared between the feature packages. I tend to adopt an approach similar to that, and because we have a loosely coupled code base that uses dependency injection, this becomes somewhat straightforward. So let's go ahead and do that. We'll take everything related to the onboarding feature, put it in the onboarding feature package. Everything related to the user's profile in the profile feature package. Everything related to the map into the map feature package. Everything related to the details of a coffee shop goes into the details feature package. And then we're left with a couple of types here. Those are our cross-cutting concerns. We'll create a separate package for those called the authentication. This authentication package is used by our onboarding feature to sign in the user and our profile features to sign out the user. And just a reminder, we didn't get rid of our object graph. It's just distributed now in these different Swift packages. So now that we know we have an object graph and we have a loosely coupled code base, the question we need to answer or ask ourselves is, how do we compose the object graph? And that brings us to the composition route. One publication that answers this question, how do we compose the object graph, and answers it with an answer that resonates really well with me, is this one: Dependency Injection, Principles, Practices, and Patterns by Steven van Dersen and Mark Seemann. It answers the question, how do we compose the object graph, by introducing the composition route. And it introduces the composition route like this. A composition route is a single logical location in an application where modules are composed together. Now, in this definition, a single logical location means that we need to identify a point in our app where the composition of modules is logically organized. So we have a task at hand. We are told that this location should be as close as possible to the application's entry point. Okay, so that means the composition of our object graph needs to be one of the first things to happen when we launch our app. All right. We are also told that the composition route, that is the place where we compose this object graph, can span several types. This is key. This is an important thing to remember because this is something I did wrong when I started working with the composition route. I thought the composition route was just a single type, maybe a struct named composition route, or a single file in my app, but that's not the case. Rather, it's a layer in our app that can span several types, several functions, several properties. And this layer is made up of composers. Now, a composer is really just composition route lingo for a property or a function. Composers are just properties and functions that create part of our object graph. We'll have a closer look at that later. So here's another visualization of our app with these loosely coupled object graphs that we just threw into Swift packages. And you can take my word for it. It's the exact same types that we just saw in the other visualization. Now it's just laid out differently because this is a common way of visualizing the composition route. And with our objects, our object graphs laid out like this, we can introduce the composition route in the middle here. Now, the blue lines here indicate all of the objects or types in our object graph that the composition route is responsible for initializing. And you might say, hold on, Simon. There are lines to every single of these types, every single of these objects. And that's my exact point. The composition route is responsible for creating the entire object graph. This also means that all of the Swift packages that we just created, the composition route depends on. It's allowed to depend on all the packages in our system if it needs to. And we'll see how that works in just a second. But as I just mentioned, the composition route is a layer made up of composers. And I think it's time that we see our first composer. So I'll bring it up here. It's a composer named profile view, and it returns an instance of some view. Specifically, this composer returns an instance of profile view. So the composer, which is just a property, creates and returns this instance. And to do that, it also needs to create the dependencies of the profile view, in this case, an authenticator. And in order to create that authenticator, it also needs to create the dependencies of the authenticator. In this case, a keychain credential store that is something conforming to credential storing. And the profile view also has a dependency on this repository that we saw earlier. This is a composer in the composition root. A property creating a tiny object graph that we can then use later. That's how a composer looks. Now, let's get into the details and have a look at how the composition root fits in our Swift-based app. So remember earlier we took all of our types and threw them into Swift packages. I showed you that using one visualization, and I'll just show it in this visualization as well. So we take all of the same types, throw them into all of the same Swift packages, and then everything that remains, everything that we have to deal with now is the composition root. And I think that raises the question, with all our UI and business logic living in Swift packages, what does that mean for our app target? Well, it turns out that our app target is the composition root layer. When everything else lives in separate Swift targets, we can regard our app target as the entire composition root. Now, this might be a bit abstract, but I'll show you how that works. But just to reiterate, we just learned that a composition root lives in our app target to create the object graph using composers. And we also learned that a composer is just a property of a function. Now, let's head into Xcode and see how this actually works. And let's get our hands dirty with some code. So I'll open up our example project here, the coffee shop's example app. And the first thing I want to show you is our Swift packages. You'll notice that we have the 4 feature packages that we just created, details, map, onboarding, and profile feature, along with the authentication package we just created, and then 2 more that were previously left out for brevity, but those are just other packages containing some cross-cutting concerns. That's our Swift packages. Then I'll show you the app target. And you'll notice there are only 2 Swift files here, which kind of emphasizes that there's not a lot going on in our app target. It also emphasizes that our app target is really just the composition root layer. And I'll show you how that looks. You'll also notice that there are a bunch of imports here. And to many of you, this might be a red flag. But this is actually okay because we're in the composition root. Remember, the composition root is allowed to depend on all packages. It's the entire point of the composition root to depend on our packages and tie them together. Now let's scroll down and see how our coffee shop's app struct looks. That's our conformance to the app protocol. All Swift UI-based apps have a struct that looks somewhat like this. The first thing we'll notice is that this struct is annotated with @main. Again, all Swift UI-based apps have a struct that's annotated with @main, and this tells us that the struct is the main entry point for our application. That is, it contains the code that's executed first when the system hands off control to our app. And remember that just a second ago, we learned that the composition root should be one of the first things to happen, or should reside as close as possible to the application's entry point. And we don't really get any closer than this. So this seems like a great place for our composition root to live. We'll also see 2 composers, and they're just properties, really, creating and holding a reference to a single object. But they are composers in the composition root world. There's the credential store that we've already seen, and then there's a property named DB, which holds a reference to Swift Data DB, which just sets up our Swift data stack. They're composers. And they're composers that have the singleton lifetime. Now, that's not to be confused with the singleton design pattern. The singleton lifetime just means that we have a single instance of these in our composition root, in our object graph, and we can use these single instances and inject them in different parts of the object graph to share state. For example, to share the user's credentials. Then we have another composer named body, which creates the main scene to be displayed when the user opens the app. Specifically, it creates our onboarding view that lives in the onboarding feature package. And in order to do that, it also creates its dependencies. For example, this authenticator. Authenticator here is a property on self. And this shows a key concept in the composition root design pattern, namely that one composer, in this case body, is allowed to call other composers. So authenticator is a composer that we'll see later. We also create the view to be displayed when our user is logged in. That is, we pass a closure, specifically a view builder, to our onboarding view. That onboarding view contains a tab view, and it contains the map view and profile view. Again, map view and profile view are composers on self, or properties on self, and they're really composers that create a part of our object graph. We'll see how that looks in a second. This shows another key concept in our composition root design pattern, namely how we can tie two loosely coupled Swift packages together, or more. Actually, we're tying 3 packages together here, namely our onboarding feature, the map feature, and the profile feature. So these packages don't know anything about each other, but it's the responsibility of the composition root to tie them together. For example, to show a map view and a profile view when the user is logged in. Now let's scroll down to the map view and see how that composer looks. And again, it's just a property on our abstract here called map view. It returns some view, specifically a map view. And when creating that map view and creating the object graph for our map feature, we also need to create the dependencies of our map view. And in this case, we have a bunch of dependencies. I just want to highlight some of them. Specifically, this visited coffee shop repository that we use. Notice that we have a variable named visited coffee shop repository where we assign the value of self.visited coffee shop repository. That's another composer on self. And then we inject that value in multiple places of this subgraph. We call that the scoped lifetime when we share state, or we use a single instance to share state in a limited part of the object graph. We also see our third and last lifetime here, the transient lifetime, where the lifetime of a dependency is tied directly to the lifetime of the consumer. In this case, the service's lifetime is tied to the lifetime of the app details view. Once again, we see how we can tie loosely coupled feature packages together. So the map doesn't know about our details, the details of a coffee shop, but we inject those details into the map here. So let's just have a quick look at how this app details view looks. That's our second file in our code base. And I just want to show you this to convince you that the composition root can span multiple Swift files and can span multiple types. You'll see there's not a lot going on here. There's no significant UI, there's no significant business logic. It really just serves as a composer that creates a tiny part of the object graph that we can then use later, as we just saw. So let's have a look at our two of our remaining composers. I want to show you the authenticator composer that we've already used a couple of times. And I want to do this to show you the benefit or the advantage of having tiny composers like this, because this is a tiny composer. It just returns a single object. So the authenticator creates and returns an object conforming to the authenticating protocol. So authenticator is a property on our app, returns some authenticating, specifically an authenticator. In order to create that authenticator, we need to inject our credential store. That's the one we just created at the very beginning, or at the very top of our abstract, and then we inject it here. That's the one with the singleton lifetime. Now, here we use the authenticator in our profile view, or to create our profile view, but we could use it in multiple places in our object graph. So multiple places of our object graph could call this composer and return multiple instances. And this highlights the benefit of having tiny composers like this. Because if we wanted to run our app with some different logic, for example, to mock a user's login, we would just locate the relevant composer, in this case, authenticator, and return a different instance. For example, a mock authenticator. And now we've changed the behavior of our entire app. So the user is logging in with a mock behavior, and they're logging out with mock behavior, with just a single code change, or line of code change. That's the advantage of having tiny composers. You can really modify your object graph really quickly. Now, I want to show you how the composition root affects SwiftUI previews. So I'll just dive deep into our map feature package. I'll pull up our map view that we've already seen. And then I just want to pause for a second to show you or highlight part of the map view's initializer. Here we see the view builder, we see the initializer, and the view builder is highlighted. A view builder is highlighted. And just remember that a dependency in dependency injection doesn't have to be a struct or a class or an enum or whatever. It can also be a closure, as for example a view builder in this case. And this is what allows us to tie the map feature and the detail feature packages together. So the map feature doesn't know what the details looks like. The map feature just knows that at some point it would like to present details, and when doing so, it uses the closure passed here. So it supplies a coffee shop marker as an argument, and then it gets back the details view. That's how we tied the map details and the map feature and the details feature together earlier. Then I want to resume to the SwiftUI previews. So you'll see we have a somewhat rich SwiftUI preview. We can pan around the map. We can see some mocked markers, and we can select one and see mocked details. And the way that that's implemented, we see on the left here. It's really just the map view initialized, and then we supply this, what's it called, preview coffee shop marker service, quite the mouthful of a name, and then a mocked details view that just shows this text coffee shop details. Very creative. And we can do this because we allow ourselves to consider each SwiftUI preview to be their own teeny tiny composition root. And we really do that because it's convention that a SwiftUI preview resides in the file that implements the view. So we can't really move it to a shared composition root layer. So it actually turns out that the introduction of the composition root hasn't really affected our SwiftUI previews. Handy. If anything, it has made them better, because we now have a loosely coupled code base that uses initializer injection. So we can inject a preview coffee shop marker service like this that shows hard-coded data. And I just want to spend a second showing to you how this looks. So I like to have a folder in my view layer named previews, where I have the Swift types that implements the hard-coded data to be used in my SwiftUI previews. It's sort of similar to the preview assets that Xcode might create for you by default. Now, let's turn our attention just for a brief moment to unit tests. So I'll find a unit test inside our map feature here. And there's quite a lot going on here, but I'm highlighting the important parts. Now, this is just a test that verifies that when we rate a coffee shop, that the marker on the map changes color from black to blue or yellow or whatever. And the service we're testing here is this persistence annotating coffee shop marker service. I don't know, I have a thing for long names, I guess. Really unhandy when you're doing a presentation. But in order to create this service, we have to inject its dependencies. That's these two, a service and a repository. And in order to inject those, we just create them on the lines above, the types, and then we pass them to the initializer of the service that we're testing. And you might say, well, that's simple, and that's how we've always done unit tests, and that's actually my point. Once again, we allow ourselves to consider a unit test to be a tiny composition root, because everything else is not practical. So the introduction of the composition root hasn't really affected our unit tests. Again, if anything, it has made them better, because we have a loosely coupled code base that uses dependency injection, so we can actually test our components using stop data, mock behavior, and so on. So with this, in just, 27 minutes, we've seen how to use the composition root to compose an app. We've also convinced ourselves that the introduction of the composition root hasn't affected our SwiftUI previews or our unit tests. We can inject mock behavior into our unit tests. We can inject stop data into our SwiftUI previews, just like we always have. And in fact, we can consider each test case and each SwiftUI preview to be their own tiny composition root. So I just want to change gears for a bit and talk about dev apps and how they relate to the composition root. At Fremna, in Fremna, Denmark, we recently started adopting dev apps. I say recently, I think it was 2 years ago or so by now. And I think this was a concept that was originally presented by Airbnb. So a dev app is a separate app target that launches directly into a feature of your app. So instead of launching your entire app and going through various flows, you just launch directly into the relevant flow. So we have 4 dev apps in our code base, one for the onboarding, one for the map, one for the details, and one for the profile feature. And these enable us to quickly iterate on features. So for example, to test the onboarding feature, we don't need to launch our app, log out if we're already logged in to get to the onboarding, then go through the flow, then end up being logged in, and then do it all over again. Instead, we just launch directly into the onboarding app, which will typically use mock behavior or stop data, so they're deterministic every time we run them. And these dev apps are actually just app targets that contain a composition root, just like the one we just saw in our coffee shops app, except this composition root is much smaller because it's only It's only concerned with a single feature, the onboarding or profile feature or whatever. So they're teeny tiny composition roots, and they're really easy to create when we use this composition root pattern, when we use dependency injection, and when we have a loosely coupled code base. And if you'd like to see how we've created these dev apps, or if you'd like to see how to create a composition root, you can check out this example project. That's the code base we just saw, the example project we just saw on github.com/shapehq/coffeeshops example, or you can scan the QR code here. I'll just give you a second if you'd like to scan it. So, some of you might have been thinking throughout this talk, what are you talking about, Simon? Why on earth would you want to make life so hard on yourself? Haven't you heard about this new fancy framework or this even fancier design pattern? Why would you want to create an object graph by hand using initializer injection? That's a fair question. And I have heard about that new framework, and I have heard about these fancier design patterns, but they're just not for me. My experience with those are that they mostly introduce anti-patterns in our code base. They either hide dependencies so we cannot see the dependencies of a consumer without looking at the internals. You might know this from SwiftUI's environment. You don't know what behavior SwiftUI is running with because it's not clear from its interface. It could also be that this new framework or these fancier design patterns, they create a tight coupling to a dependency injection container that's then spread around your code base. Or they create a tight coupling to the framework itself. So then that's just spread around your code base. Both of these, hiding dependencies, creating tight couplings to these dependency injection containers or frameworks, they're all red flags in my book, and I really want to avoid it. So no, I don't use this new framework, and I don't use fancy design patterns, because I just showed to you how using pure dependency injection with initializer injection, we can actually prevent these two downsides. Another concern I often hear is, yeah, this is all fine and dandy for your tiny coffee shop's example project, but this doesn't scale. I don't know what to say. I don't know what to tell you. Yes, it does scale. As I said, we're using this at Framna in much bigger apps, in way, way bigger apps, and we've done that for the past couple of years. It does scale. Even if you're not using the composition root pattern, you already have an object graph in your code base, and that's whether your code base is loosely coupled or not. The object graph is there, but the introduction of the composition root pattern, the introduction of initializer injection, will make that object graph more obvious. So you'll be better equipped to reason about it. So for example, if someone were to modify the object graph in our code base, for example, by modifying our authenticator to depend on a logger, maybe we wanted to log when someone was signing in or signing out or whatever, then they'll add a logger here. Well, that modification to our object graph will be surfaced as a compile time warning or error all the way up in our composition root layer. So now we need to tweak this authenticator composer to add the logger in the initializer or pass that as an argument in the initializer. Some might think that's unhandy. For me, this is a great way to deal with dependencies because it makes the relationship between our types obvious. And any adjustments required to deal with this changing relationship between the objects become straightforward to deal with because it's surfaced as a compile time error. I would just add an argument here, or if this logger was introduced in multiple parts of my object graph, I might create another composer, which is just a property, and then I'll call that composer wherever it's relevant. It's really a quick fix. So we've just seen how pure dependency injection and the composition root enables us to build loosely coupled Swift apps. And if you want to learn more about that, if you think that's exciting, as I do, then I recommend to read this book, Dependency Injection, Principles, Practices, and Patterns by Stephen van Dersen and Mark Seemann. That's where I learned about these concepts, and then I've sort of adapted them to a Swift-based code base. And if you think moving code into Swift packages or DevApps is interesting, then I strongly encourage you to read this article, Designing for Productivity in a Large-Scale iOS Application by Michael Backhand at Airbnb. I think that's where DevApps were originally introduced, but I could be wrong. I'll just give you a second to scan the QR code. And if merchandise is more your thing, come find me afterward. I brought some pins and I brought some stickers, and unlike the mobile Warsaw organizers, I actually have the stickers tonight. So, sorry. Yeah, so with this, I encourage you to think about how you can use pure dependency injection and maybe the composition route to build loosely coupled Swift apps. Thank you for your time. If there are any questions, maybe we can take them now or we can take them afterwards.
Yeah, we can have 3 questions.
3 questions. There's one up here. Oh, wow.
Simon, great talk. Thank you very much. I have a question regarding DevOps, a concept which I think I've been using for like 10 years or so. But the problem I encounter sometimes is that in a big team, yeah, I create this DevOps, and then nobody else uses it. It's like nobody else is I guess the reason to me, I think it's absolutely the best tool to test and develop up in separation when you can like just create one feature, one screen and test it completely separately. You have quick compilation time. You can basically separate all the side effects. But how do you, in your big company, in your big agency, how do you force people, how do you encourage people to use and maintain those DevOps? Because you have to like make sure they are up to date, they compile, and so on.
Yeah, great question. You just highlighted all the benefits of using DevOps, which I should probably have done in my talk. So thank you for that. But yeah, it's a great question. So I think encouraging people to use them, I'm not going to force anyone to use them. I'll sit down with them, show them the benefits, and if it's not for them, it's not for them. But typically, I get quite good response when introducing people to DevOps because of the benefits you just outlined. Now, the issue is that your DevOps might become outdated. Because, for example, if you're using this a composition route pattern and you have different composition routes in your host app, in your app target, in your different DevOps, then if you don't use these often, then they'll rotten, and then they won't compile at some point. So what we've done is quite simply have a PI check that ensures that all of our DevOps can compile. So I have a small script that fetches all the targets from our Xcode project and ensures that all of them can compile before we merge any code. I'm happy to share that with you if that's handy.
Thank you.
Hi, Simon. Again, very great presentation. Thanks a lot. I have a question about this pattern, if you maybe have used that in production in some application that has some crazy dependency flows, maybe more dynamic, like multi-user accounts, like you can log into multiple different accounts at the same time on the single app, then there will be like same type of repository, but multiple different instances because of different users, some like crazy stuff, and how it worked. Like,
I'm not sure I fully understand the case here, to be honest.
yeah, because like the composition route is seems kind of static. Maybe it's not really static; it's actually dynamic because it's computed variables. But I think it can be quite hard to comprehend how those dependencies cross different boundaries.
Right.
If you introduce some non-standard flows, and that kind of flow could be like multi-user app, where you can log into multiple accounts, like maybe Facebook, you have your personal account and business account, and they somehow cooperate.
So I think I understand now. It's getting complicated, but you're right that the composition route or the object graph is somewhat static in some sense, but the behavior within each of your components doesn't have to be. So if you have a multi-user setup, then you might have some component observing whatever user is logged in, and then injecting behavior that reacts on these changes, right? So then you have an object graph that can kind of handle this change in users. I don't know if that answers your question.
Give another round of applause for Simon.
Thank you.